Welcome back to Wages and Employment at Wilfrid Laurier University. In our last video, we used our basic labor supply model to derive an individual's labor supply schedule. Today, we are going to look at how we measure whether the model is doing a good job of predicting real-world labor supply behavior. Now, for reference, you should pair this video with readings in Chapter 2 of your textbook. The journal references here are for further reading if you are interested. We start here by returning to our basic labor supply model, and you should recall this diagram. One of our key predictions from this model was that when people are offered a higher wage rate, say at W2 here, we expect to see them enter the labor market and participate. So we expect to see an association between variables associated with higher wages and the likelihood of participation. When we look at the data, we often look at the behavior of married women. Why? There's a general sense that the gendered social norms have resulted in a situation where women have had a bit more flexibility in their responses to the market. That has certainly changed a great deal over time, but we can say that unlike single parents or dads who are the main earner in a family, many married mothers will change their labor supply with more ease when circumstances change. So we start there, and in this table, which is quite similar to that in table 2.2 of your text, we see that participation rates of married women within education groups vary quite a bit. For example, the participation rate of women with a university degree is 83.7%, 34.1 percentage points higher than women who did not complete high school. Some of that difference may be related to things like age, their children's age, or even their spouse's income, so we can control for those in a regression here and show the adjusted differences between groups in that last column. Even after the adjustment, the participation rate of women with university is 22.4 percentage points higher than those with less than a high school graduation. Now, since the higher education is associated with better wages, this positive relationship that we see here between education and participation is consistent with our model. Here, when we raise non-labor income in our basic labor supply model from YN1 to YN2 here, we expect some people will leave the labor market, reducing their hours to 0. So we should expect a negative relationship between measures of non-labor income and their likelihood of participation when we go to the data. So what do we see in the data? Here we can think of a spouse's income as non-labor income. It's money you would normally have access to, or at least some access to, but don't have to work for in the paid market yourself. That's a negotiation within families separate from what's going on in the labor market. So here we see that, generally speaking, women whose spouses earn more are actually more likely to participate in the labor force, although there is some drop at top incomes here. But recognize these would be the top earners here over $150,000. More importantly, this isn't consistent with our model. Why is that? In today's world, women with higher earnings potential tend to marry men with higher earnings potential, so that their preferences for work are correlated. We call this assortative mating. This is an omitted variable in our simple analysis here, confounding any income effect associated with higher non-labor income, and would require much further analysis to pick that all apart. So the descriptive statistics for married women are a good first step for thinking about how well our model describes the world, but we want some general estimates of the shape of our labor supply schedule, telling us how much labor supply changes for a small change in the wage rate. For this, we need to define the labor supply elasticity. We like to work with elasticity because it's unit-free, making it easier to compare across regions or think about different ways of measuring labor supply. It's also nicer to interpret. We start with defining an uncompensated elasticity of labor supply. This is the percentage change in labor supply that results from a 1% increase in the wage rate. Now recall here that there are both income and substitution effects at play, so we don't know if this elasticity will be positive or negative. Why would we want this elasticity? Consider a policymaker proposing a wage subsidy, so that every hour a person works, they'll get a boost to their wage. To decide if it's worthwhile, they'd want to know how much more people will end up working. The total or uncompensated elasticity is broken into two parts. First, we measure the income elasticity. This represents the change in labor supply for a 1% increase in non-labor income. Recall, income effects are expected to have a negative effect on hours worked, so the income elasticity is negative. When we're looking at changes in wages, this will tell us how much less people will work because they gain higher incomes when there's an increase in the wage rate. The second part is known as the compensated elasticity. This is meant to reflect that part of the overall change in hours worked associated with increasing the price of leisure, but not making you better or worse off, as though you're being compensated by taking away some part of the extra income you might have gained. This seems an odd construct, but consider how it has policy relevance. Consider a wage subsidy that gets taxed as a lump sum amount. That raises the price of leisure so that you'd be inclined to work more, but also eliminates the income effect associated with reduced hours. Here, we'd need to be able to separate the substitution effects of a wage increase from the income effect. I'll note that it's worth taking the time to understand that if you want to understand how carbon taxes with household rebates work to nudge people to substitute towards lower emission activities. Okay, so what does our literature tell us about the elasticities of labor supply? This is a table quite similar to Table 2.3 in your 8th edition textbook, but updated to reflect more recent estimates. Here, we group men and single women together and considered married women separately. Again, given the greater flexibility in the labor market that we expect the second group to have. For men and single women, we see the compensated wage elasticity is positive, as expected, and ranges between 0.1 and 0.3. So we would say that a 1% increase in wages is associated with a 0.1 to 0.3% increase in hours worked after compensating for any extra income. Income effects are close to zero, with some estimates that are negative. So we expect people to work less when they receive more non-labor income. You'll notice the estimates for married women are much lower than what's found in the 8th edition of your text. Older estimates, around 0.9 for a compensated elasticity, are based on surveys of women in the 1970s and early 1980s. Things have changed a lot. So that the difference between married women and everyone else are much smaller than they used to be. But we do still see married women begin being more responsive to wage changes, as reflected in a slightly higher compensated wage elasticity than for men and single women. I'll point out that the estimates here are from the US, but are consistent with recent Canadian estimates in the literature. Overall, there's a few key points here that we can take from the literature. When you sort of take it as a whole, we see that the labor supply schedule is slightly upward sloping. For men, we know that that labor supply schedule is likely to be slightly backward bending. If nothing else, we do see that a large part of it is fairly inelastic. For women, that labor supply schedule remains more strongly forward sloping. And we also see in the data that low-income workers tend to have higher labor supply elasticities. So at lower wages, people tend to be much more responsive to small increases in their wage. Now, there's one major point here that I want to emphasize and add to what you're seeing in your textbook, and that's that the labor supply elasticities that we see, they do change quite a bit over time. Particularly for women, we have seen a great deal of evidence looking over the course of many decades, suggesting that labor supply elasticities of married women have fallen substantially since the 1980s. There's also evidence out there that men's labor supply is changing. It's certainly not as inelastic as it used to be. And perhaps as women have become more attached to the labor market, men have gained some flexibility in their labor supply as well. So now in our next video, we are going to look at some applications of our basic labor supply model and consider some extensions. See you then.